States of matter. Specific heat capacity. The amount of heat required to raise the temperature of a solid body depends on its change in temperature, delta T, its mass, m, and an intrinsic characteristic of the material called specific heat, C. This is measured in units of joules, J. So Q equals mc delta T is used for specific heat capacity, where Q is the heat and energy in the unit of joules, m is the mass of whatever is being heated in grams, and C is the specific heat capacity, and the delta T is the change in temperature in the unit of Celsius. So an example would be how much heat is absorbed when 500 grams of water is heated from 25 degrees Celsius to 35 degrees Celsius. So they give us a specific heat of this liquid water as 4.184 joules per gram Celsius. So we go to the equation Q equals mc delta T, and we plug in the known variables. So to get our delta T, we have to subtract the 35 degrees Celsius and the 25 degrees Celsius to get our temperature change of 10 degrees. And we can plug this into the Q equals mc delta T equation, where the m would be 500 grams times the C specific heat when the water is liquid, which is 4.184 joules, divided by grams Celsius times the delta T, which we calculated to be 10. So when you solve this, the Q would come to equal 20,920 joules. So that would be the heat absorbed when 500 grams of water is heated from 25 degrees Celsius to 35 degrees Celsius. Another example would be a 50 gram block of glass absorbs 330 joules of heat energy. How much does the temperature of the glass rise? So they give us a specific heat of this block of glass as 0.5 joules per gram Celsius. So we use the equation Q equals mc delta T to calculate the change in temperature of the glass when heated. So with 333 joules of heat energy, that is our Q, and that is equal to the mass of the block of glass, which is 50 grams, times the specific heat, which is 0.5, times the change in temperature, delta T. So when you solve this in our calculator, we can get the change in temperature to be 13.32 degrees Celsius. So that means when the 50 gram block of glass is heated with 333 joules of heat energy, the temperature of the glass will increase by 13.32 degrees Celsius. So the heat of fusion. So solids can be heated to the point where the molecules holding their bonds together break apart and form a liquid. So when a substance converts from a solid state to a liquid state, the change in enthalpy, delta H, is positive. However, if the substance is transforming from a liquid state to a solid state, the change in enthalpy, delta H, is negative. This process is also known as melting or freezing. So we know to use the heat of fusion when they say melting or freezing in the equation. When a solid undergoes melting or freezing, the temperature stays at a constant rate until the entire phase change is complete. So for heat of fusion, we use the equation Q equals m times delta T of the heat of fusion. Similarly, there's a heat of vaporization. and that is the amount of energy, enthalpy, that must be added to a liquid substance to transform a quantity of that substance into a gas. This is also known as evaporation or condensation. Enthalpy changes of vaporization are always positive, and this is where the heat is absorbed by the substance, whereas enthalpy changes of condensation are always negative, where heat is released by the substance. And we can use the equation Q equals M times delta of the heat of vaporization. And this is very similar to the heat of fusion, and this can also be combined with our previous equation Q equals MC delta T. So an example, how much heat is needed to melt 500 grams of water, where the heat of fusion is 334 joules per gram. So we have to use the equation for the heat of fusion because it says melt. So we're going from a solid to a liquid form of that water. So since it's going to be heat of fusion, we use the equation Q equals M, and the M is the mass in grams, and the mass in grams of the water is 500 grams, and that is times the delta H of the heat of fusion, which is 334 joules per gram. So when you multiply this together, we get our Q to equal 167,000 joules. So that 167,000 joules is the amount of heat required to melt the 500 grams of ice into 500 grams of water. So how much heat is needed to boil 500 grams of water? And they give us the heat of vaporization as 2,260 joules per gram. So we use the equation Q equals M times delta T of heat of vaporization. So they give us the 500 grams of liquid water, and since that is heated with the heat of vaporization 2,260, you multiply the mass M 500 times 2,260, and the heat needed to boil the 500 grams of water would be 1,130,000 joules.